Yes, so it's my great pleasure to introduce Douwe Kiela, who is head of research at Hugging Face. Before he was a research scientist at Facebook AI Research, and he did his PhD and MPhil at the University of Cambridge. And he's been working on a lot of things, more recently on machine learning, broadly on machine learning and natural language processing. And yes, and today he's going to talk to us about rethinking benchmarking in AI, evaluation and service, and dynamic adversarial data collection. Over to you, Douwe.
Thank you very much for that introduction, Andreas. And yeah, thanks for the invitation as well. Sorry I can't be there in person. I think it would have been much nicer if I was up on the stage there, but it's a long flight from California. So we figured this is easier to do. So I'm going to talk to you about rethinking benchmarking in AI. But before I talk about that, I figured it's maybe useful for you to know where I'm coming from. So if you haven't heard of any of my research, the main question that's been the driving question of my research agenda over the past decade has been about how do we get meaning into machines? And with meaning there, I mean real meaning in the same way that humans have meaning and not fake meaning in the sense of, for example, the Chinese room experiment, where it's a bit unclear if the person inside this room actually speaks Chinese, if they're only following rules in a book. So I wanted to try to take us to the next level. And so where that next level is a bit unclear because of how we measure progress. So what you can see here on the left is a graph of various benchmarks in the field of AI. So things like MNIST took a very long time to saturate, but things like glue have saturated almost within the year, and super glue is not on this, but that's also saturated. So it looks like we're making crazy progress. To such an extent even that some people at Google, who are now no longer at Google, were very worried that these AIs have become sentient. So we're really making crazy progress. But at the same time, I think everybody agrees that, or at least if you work in AI, then you would agree that while the progress has been remarkable, we are definitely not yet done. So there's a lot of work to be done. These systems are not at all as good as humans at almost any of these problems. So that seems to suggest that we have a measurement problem. We are not really clear on how to evaluate our systems. In other words, there is something rotten in the state of the art, and we need to fix that. And so for the past couple of years, I've been working with lots of very talented, amazing people on lots of different evaluation projects to try to see if we can improve the current status quo. So for me, one of the starting points on that journey was this adversarial NLI paper where we tried to come up with a new benchmark that was designed slightly differently. I'll talk about that in a bit. So the outline of my talk here is I'm first going to give a little bit of an indictment on AI evaluation and complain about all the problems we have. And then I'm going to talk about some potential solutions. So I'm not claiming that these are like the full solutions, but at least they're attempts at rectifying some of the issues that we currently have. And so that's some work at Hugging Face on the Evaluate library and evaluation on the hub, and some older work on Dynabench, a platform for rethinking benchmarking in AI. So I don't think it's I think you cannot overstate how important evaluation is, but it seems to be something that people don't really care as much about as scaling up models and doing cool new fancy math and algorithms and things like that. While we really are in an evaluation crisis currently in the field. So I would really encourage people to think about this much more deeply before it's too late or before we have real problems with these systems, because they're starting to be deployed all over the place in the real world. So what are these problems? So one of them is what I already talked about in the beginning with that graph. Is that these systems are starting to saturate the benchmarks, which means that they're starting to outperform humans on these benchmarks. But we all know, as I said, that it's not really true in the real world. So that suggests that there's something wrong with the benchmarks. These data sets, so benchmark data sets, they also contain lots of biases and annotator artifacts. There's a rich literature on this by now, where various data sets have been shown to not be as good or to not measure the thing that they're claimed to measure. And one of the problems here is that neural nets are especially good at picking up on these sorts of artifacts. So we have to make sure we safeguard against this happening in our evaluation. Then we also have a bit of a reproducibility crisis. So self-reported results in papers cannot necessarily be trusted because very small implementational differences going from like your sampling rate or like how you construct a prompt or things like that, even in your evaluation pipeline. So not just in your training hyperparameters, but just in how you evaluate or like what blue score implementation you use may lead to very different results. So that's a real problem if we want to make sure that we evaluate things in a rigorous fashion. And to add to the woes there is that old models are not easy to evaluate on new data sets and vice versa. So ideally, we would have some backward compatibility where if there's a new data set coming out, we would automatically be able to evaluate the old model on the new data set in exactly the same way that that old model evaluated the old data sets. Then we are just making it very difficult for ourselves. So to do proper evaluation, you need to do this at a large scale. So many models, lots of baselines, which is good, lots of data sets, which is also good. But doing that is not easy at all. And as you can see here, this is the trend of the number of data sets per paper and the number of metrics per paper in EMLP over the years. So that number is steadily going up. So we have more metrics, more data sets. We actually have less significance testing, which makes me a bit worried. So it's just very difficult right now to scale with this. So we think that if you make things easier, then people will start doing better things. So establishing better best practices. And so currently we just don't have really good best practices in many of these situations. There's also a bunch of implicit assumptions in what we do. So if you're familiar with this classic book from Vladimir Vapnik, is we are sort of haunted by Vapnik's ghost in the sense that all of the machine learning that we ever do has this assumption that the train and the test set are IID. And so while that makes a lot of sense for machine learning from a theoretical perspective, and it allows us to really understand what the bounds are on statistical learning, in modern day AI systems, we seem to sort of move past this IID assumption. So we pre-train on large data from a different distribution, and then we prompt those pre-trained models to elicit certain behaviors, which also kind of moves them out of the distribution. So arguably that assumption is not really true anymore. And one of the real problems with especially language producing AI is that lay people, so just regular people in the street, when they interact with the system in natural language, they will assume, because natural language is the quintessential human characteristic, that this AI system will have a similar language understanding to humans. So we take an intentional stance to everything. But especially when systems produce language, we assume that they have the same kind of strong generalization and intentionality that humans have. And we know that that's not really the case because they're trained in this IID setting. So if you have strong generalization, you should be able to generalize to OOD as well. We have a single metric focus. So we only care about accuracy, at least in a lot of papers. It's slowly starting to shift. Where we focus on this one kind of ranking score that puts you somewhere on the leaderboard, and everybody wants to be at the top of the leaderboard. And so you can think maybe we should have different metrics, not just accuracy based, but also think about efficiency and fairness and bias and things like that. And finally, what we really care about with these AI systems right now. So before, like 5-10 years ago, this was a bit of an academic exercise, but right now these AI systems are just being deployed in the real world all over the place. So what we care about is, can this AI system successfully interact with humans for the task it is designed to do in a way that is aligned with human expectations and acts in humans' best interest. So you might have seen this paper from Anthropic, where they proposed this helpful, harmless, honest kind of motto to prompt language models to make sure that they have this kind of alignment. But this is not at all what we're currently measuring in our evaluation. So we have a static test set. We just look at accuracy on that test set. And then if we have a high number, or if we saturate and we outperform humans, then we're very happy with our success without really reflecting on what we're doing. So I think those are all very serious problems. So as I said, I've been working for quite a while on trying to come up with better alternatives or establishing better best practices. So for this first part, evaluate and evaluation on the hub, let's work with a bunch of amazing colleagues at Hugging Face, where we've tried to improve some of these issues. So if you haven't heard of Hugging Face, which these days is becoming quite rare in AI, I guess, but if you don't know what Hugging Face is, we are a startup on a mission to democratize good machine learning, one commit at a time. You've probably heard of us because we have some very famous libraries like the Transformers library and the datasets library. So we really care about the open source ecosystem and open science and working together with the community to try to improve everything that we do and grow the pie of AI together. And so what we recently did is we introduced a new library specifically focused on evaluation. The old datasets library used to actually be called NLP, and it included some metrics. We decided to take those metrics, split them out, and add a lot more useful evaluation related capabilities to this new library. And so as you can see here, it's very easy to just load metrics that you might be interested in directly from this data set. You can implement your own metric and push it to the Hugging Face hub for other people to use. And it's really a couple of lines of code for you to have an implementation of a metric where you know that it's correct and where you know that you can rely on it and other people can use exactly the same implementation. So in this library, we distinguish between metrics where you have a ground truth, measurements where you just have a set and you want to get a number, and comparisons of predictions. So something like McNemar's test or Wilcoxon or something like that, where you want to compute statistical significance or do a bit deeper model comparisons. So this is all open source, and we hope that this can help us move towards a standardized canonical set of implementations for these things. And in order to do that, I think we should also be very careful with understanding the limitations of the metrics that we're using. So very similar to model cards and data sheets, which you might have heard of, which are all about good documentation for models and data sets, you can do a very similar thing for evaluation metrics, where something like accuracy, if you're a practitioner, then you probably know that it has some issues, especially if you don't have a balanced data set. But these are things that need to be documented somewhere. So we have these metric cards on the Hugging Face hub for all the metrics, and you can really get a good understanding of how the metric works and also what its limitations and biases are that you need to be aware of. We also even provide interactive widgets, so you can really develop a good intuition for how a metric behaves just by adding some new data here and then trying to submit it, and you'll get a metric score coming out of that. So we're really trying to make sure that people know what they're doing. Then once you have a metric for yourself, let's say you're developing a metric with your own team that you really care about, then you could push that to the hub and you can make sure that other people can load it just like this. So there's a namespace and then a metric name. People can just load the metric directly. So maybe in the future, just like people open source models and they open source data sets, people can also open source their metrics and push them to the hub for the community to use. So hopefully we can also get a vibrant ecosystem going here around state-of-the-art metrics. Then we have this evaluator object, which is sort of like a trainer. If you've ever trained your own neural net, so using things like Lightning or the Hugging Face trainer, it's a very useful abstraction for training logic. And we have a similar thing for evaluation logic, which really abstracts away a lot of the things that you might run into, which allows you to do very nice things. So you can do bootstrap sampling, and then it gives you an actual confidence interval. You can compute standard error, things like that. So it even can compute the throughput and efficiency statistics, so you know how fast your model is actually doing these things during inference. So I think this is a really nice way to help us do better evaluation by just making things very easy. And I should say that we're not just focused on measuring models, which is what a lot of people often assume. We're also very interested in measuring data. So McMitchell, one of our researchers and crew, they've developed this data set measurement tool, which is really about trying to understand our data better. Because as we know, our models are reflections of our data. And it could be that there are lots of hidden biases in our data, for example, that we really want to be aware of. And this tool here, if you haven't heard of it, can help you understand what is actually in your data. But to sum up kind of the point here, as I said, if we make it very easy to follow best practices, and if we, as an open source community, try to develop these best practices in open source library, then we make it almost inexcusable for people to not follow these best practices. So I think as a community, we can just say, this is how we think things should happen, and make them as easy as possible. And then people have no excuse not to do it. So then the next logical question is like, how far can we take that principle? Can we make it even easier than this evaluation library for people who want to have things even easier? So what you can do is you can take evaluation to the Hugging Face hub. So we have this hub where we host models, data sets, evaluation methods. And the idea here is that we can make it super, super easy for anyone to push a data set to the hub, and then push a model to the hub, and then just at the click of a button, essentially evaluate the model on the data set of your choice. So this is what you might call evaluation as a service. So just to give you a sense of what this looks like, I'm going to actually show it to you for real, but to give you a sense of the components. So we would have a data set page. So users might be interested in like choosing the right model for a given data set, or they might be interested in separate tasks or things like that. And so on this data set page, you can trigger a model evaluation, which in the backend uses a framework we've built called AutoTrain for automatic machine learning, so fine-tuning of models, but also for evaluation jobs that allow you to compute metrics. Then what this does is it opens up a pull request. So very much like GitHub on the model card for the given model that was evaluated. Then the model owner can accept this PR on the model card, and we have these leaderboards that aggregate evaluation results across all of the different model cards. So on this leaderboard, you can see all of the data sets and all of the models that were ever evaluated using this framework. So I figured I would just give you a live demo, which is always fun to do. So I hope things will work. But so we have a data set here. It's called dog food. I don't know, you probably can't really see these images, but these are images of chicken nuggets or chicken wings and muffins and dogs. And it turns out that some dog breeds very much look like either chicken nuggets or muffins. So it's a fun, challenging data set. And what you can do here is you can click on this evaluate model button, which will take you to the model evaluator. And so in this case, we've left the metadata blank, but in most cases, you don't have to fill anything out yourself. But so you can really do advanced configuration here, figure out like what split you want to do, like how do you want to do the label mapping, things like that. Then down here, you can say, okay, like let's say I trained up this ResNet on this dog food data set, so you can use that. And then you click evaluate models. So after you've done that, that's going to trigger an evaluation job, which is going to get added to that queue. And then after a while, that's going to push this PR. And then once the PR is accepted, you'll be able to see this leaderboard here. So this leaderboard is going to show you exactly like how did the model perform, and you can compare across all the metrics that were used in the evaluation. So I think this is really nice, because now you can really trust that these models were all evaluated in exactly the same way, and I think that's really where we want to be going. All right. So we took the same principle. If you're interested in very large language models, which I think a lot of us are, we took the same principle to make it very easy to evaluate those models. So you can really just push your own evaluation data set to the hub, click evaluate. And I think the biggest model we support right now is OPT 66 billion. And we're working on like Bloom and the even bigger models. And this is completely free. You don't need any code. You just need to click a button, and then you get some evaluation results. So I think that's very exciting if you're working in that space. And we recently had a blog post about this, which you can check out if you're interested. All right. So switching to the second part of the solutions, we have been working with a really amazing crew over the past couple of years. On this platform for rethinking benchmarking in AI. It's called Dynabench. You can check it out at dynabench.org. I'll give you maybe a little bit of a tour as well in a bit. But So essentially, it's a research platform where we are just, as a research community who are interested in evaluation, we're trying to conduct this very big, maybe slightly too ambitious scientific experiment where we want to challenge current benchmarking dogma. So there are just a lot of assumptions, which are also things I talked about in the beginning, like the IID assumption, for example, or the fact that you cannot have models in the loop, or the fact that you need to have static data sets. These are all things that you can challenge, and you can try to push the boundaries of AI research. So that's what we're doing with this platform. And as the name suggests, the idea is to really try to make everything as dynamic as possible and move away from this static testing paradigm. So just to give you a good sense of what the framework is that we're doing here. Dynabench started as a platform for doing dynamic adversarial data collection. So this diagram looks very complicated, but it's actually very simple. So if you are interested in the task of natural language inference, then you would have a context and a label. So this could be like a paragraph and an entailment label. Then you ask a writer to produce a hypothesis. So a short piece of text, and then we give that the combination of the paragraph and the hypothesis to a natural language inference model, which gives us a prediction. And then we obviously give feedback to the writer if they fooled the model, or like what the model's prediction is. And what we do with the examples, if the model is correct, then they're interesting examples. So we add them to the training data. If the model is wrong, so if the target label here does not correspond to the predicted label from the model, then it's an interesting example because it's a failure case of this particular model in the loop. So obviously it's very important here because you cannot trust the writer, they're a crowd worker, that you verify all of these examples very thoroughly. And if you think that this is actually a good example and the verifiers agree, then what you can do is you can add these examples to your dev and test set. So these are the things you want to now be able to do better over time. And you can add them to the training data as well so that you can actually learn from it. So once you've collected this substantial amount of training data and dev and test data, then what you can do is you can train a new model, or so you can train this old model on this training set, and that gives you a new model, which is now even better. So the final insight is that you can now take this better model, which is like strictly stronger, and you can put it back in the loop again and do the whole process all over again. So the idea is that you really get this virtuous cycle going where the model gets better and better over time, and you get a lot of data in this process, which is useful for measuring our current capabilities. And it turns out it's also useful for training, as we will see. So just to give you a little bit of an overview of the different roles of the people involved in this platform. So we have these model builders. So this could be people like you in the audience where you have this cool model and you want to put it up to the test and see how easy it is to break it. So we have these breakers who are trying to attack the models and find weaknesses, which then lead to adversarial data. This adversarial data can be used to improve new data sets and metrics, but it can also be used to evaluate existing models. So then we have these task owners. So this could be someone who's very interested in question answering, for example, and they have a whole bunch of data sets and metrics that they care about. And so they essentially host a challenge. And so these models get submitted and evaluated on these data sets using evaluation as a service. So very similar to what I just talked about with the Hugging Face evaluation on the hub. We have an evaluation as a service framework where you submit models and then they're evaluated in exactly the same way. And then the evaluation results are shown to this model user. So the end consumer, the person who needs to make a decision about what model they are interested in for their given use case. So I'll just very quickly again give you a live demo and hope that everything works. So this is dynabench.org. We have a bunch of different tasks here, as you can see. So let's say we're interested in sentiment analysis. The first thing that you'll notice here is this big leaderboard. This is what we call a dynamic leaderboard. So it has various rounds of adversarial data and like non-adversarial data and lots of different metrics. So not just accuracy-based ones, but also efficiency-based ones, fairness-based, robustness-based. And the cool thing we think is cool anyway is that different people care about different things. So you might really care a lot more about fairness than somebody else, or you might really like if you work in like IoT settings or something, you really need to have fast throughput or like low memory or things like that. So the ranking will change depending on what you care about. And similarly, you can specify that maybe you don't care about this second round here, or you only care about the static data. So this is a dynamic leaderboard, which allows you to have a much better sense of which model to choose when. And the other thing here is this interface for finding examples that fool the model. So your goal could be like enter a negative example that fools the model. So you could say something like this restaurant was bad, like let's have a typo there or something to make it a bit adversarial. So this gets sent to the system. And hopefully the system will get back because the engineers have been making some changes. Yes. So the model predicted negative, and we said it was negative. So we didn't fool the model, but you could see some confusion there. I think if you do it with 2 A's, then it does actually fool the model. So that tells you something about how brittle a lot of these systems are. So all of the data that comes out of this gets logged and stored and can be used for future editions and further rounds of data collection and measuring improvements. So that's Dynabench. And so, yeah, just to give you a bit of an overview of what we're trying to do, it's just a very broad research program where we want to have humans and models in the loop to make faster progress and measure things better. Also try to think beyond accuracy and biases. And so accuracy as a metric, but also kind of remove biases and artifacts, have better robustness, better alignment, because this is really how these systems are used in the loop with real humans. And hopefully we can, in the process, democratize model evaluation and make research more reproducible by having everything in this evaluation cloud. So we've been pretty busy as a group. And so these are just collaborators from academia and various industry labs. So we have a bunch of new data sets. So sentiment analysis data set, VQA data set, hate speech data set. We have a bunch of work on like what this means for evaluation specifically. And we have some papers that look specifically at this method of dynamic adversarial data collection, where you have humans and models in the loop, and you try to like update the model in the loop over time dynamically to make it better. So for the rest of this talk, just kind of, I'll give you a brief overview of what we've been doing here, starting from these 3 papers. So the idea that I talked about is having a human in the loop trying to fool a model, but very obviously the next question then is like, can I just have a model trained on that human data and have the model try to fool the model? So that's the first question. And then the second question is, okay, if I am able to train a model like this, can I then give that model to a human to make them a team, essentially, where they're working together to fool this other model? So as you can see, the trend is down, and I think where we're really going as a field is where we have lots of humans and models working together with other models and humans in various ways, including in an adversarial setting. And that leads to very interesting training data and testing data. So most of this work is by the amazing Max Bartolo. So the first thing here is about improving QA robustness with synthetic adversarial data. So the basic idea is that we select a passage from Wikipedia, then we find some interesting answer candidates, so things that we might want to ask questions about. Then for these answers, we generate relevant questions. So when did Old English begin to be used? Then we do a bunch of filtering and relabeling tricks. And then out of that comes a lot of data on which we can train a new QA model. And we might even be able to repeat that process over multiple rounds. So it's a synthetic adversarial data generation method that can also be trained on already adversarial data that was gathered by humans. So that's quite nice, because what we have found in this work is that this data derived from human adversarial data really improves accuracy and robustness. So accuracy here is just as measured by like exact match or F1 score on these data sets. So you can see that the synthetic QA model is just strictly better. But importantly, it's also as reflected by this mean validated model error rate metric. It's actually also just much harder to fool. So if you take this, how easy is it to fool your model as a robustness metric, you can really see that it just becomes much harder to fool, so it becomes more robust. And it's nice to see that it also performs very well on out-of-domain tasks, which is what we want to see, right, when we want real generalization. So as I said, what you can do is you can take this model then and give it to a human and then see if that human becomes even better. And so one way to think of this is as a generative annotation assistant. So we don't just have one model in the loop, the one we're trying to fool. We have multiple models in the loop, the model we're trying to fool and the model that is helping us fool this other model. And this hopefully can help us solve two problems with adversarial data collection. One, that it's expensive because people need to be very creative, and creativity costs time and time costs money. So if you can help people be creative in fooling models, then you can drive the cost down and make it more financially feasible. And adversarial data can be noisy. So maybe you can make the data higher quality if you make it easier for people as well. So again, just to give you a concrete example, you can have something like the answer is 2. So your sort of target answer candidate is 2. The generative adversarial assistant gives you a possible question that could fool this discriminatory model here. And then maybe as a human, you can just take this thing, or you can rewrite it in a different way to make it maybe even harder. And then you give it to the model and this predicts 3 instead of 2. So it was wrong. Using this process, we made a head-to-head comparison of having an adversary in the loop or not having, not having an adversary in the loop or having an adversary in the loop. And we look at a whole bunch of different metrics here. So how long does it take to get an example? How hard is it to fool the model? How much time does it take us to generate the model fooling example? Then we have some accuracy-based metrics on like static data sets that are old-fashioned like Squad, and more new data sets like adversarial QA. And then we also look at domain generalization. So I think this is pretty telling in that this process really just leads to much better data across the board. It just takes slightly longer. So as I said, one of the things you can try to do then is can we get the time to go down as well? So you can try to improve ADC, adversarial data collection, by doing answer prompting, where you can tell the annotators like, hey, maybe you should take a look at this, maybe you should take a look at that, and then it becomes even better. So this is a whole bunch of numbers that you don't really have to worry about. The main point here is that if you do traditional data collection, then you have this validated model error rate score of this with this much time. And if you go all the way and you do dynamic adversarial data collection with an assistant, then you get much higher quality data and you get it faster. So I think that's really a very interesting way to do things. And so there are a couple of other papers. There's this paper here. It's called WANLI, where they call their own work a new paradigm, which I thought was very interesting. But I do agree with this potentially being a new paradigm, because yes, it looks like we can collect much higher quality data than static data collection methods. So it's very promising. And we can even do better than just the standard model in the loop approach if you just make humans and models work together. And so the fact that you can drive the cost down to a similar level as standard data collection is very promising. So finally, just very quickly, I'll talk about some work we did where we try to do training data analysis, where we do this over many, many rounds. So we have this model and we update it, and we keep updating this for lots of rounds. For adversarial NLI, we did that only for 3 rounds. But for this paper here, we did it for 20 rounds. So this is work by Eric Wallace. And the main thing about this work is that we constructed the test set beforehand without doing any data collection, just with experts. And this is what we really want to improve on. And so we're hoping that our annotators explore the space much better. And it turns out that actually this is what they do. So dynamic adversarial data collection works much, much better than static data collection, which works better than non-adversarial data. And so maybe this is what you would expect on the validation set, which includes some adversarial examples. But most importantly, you see the same line here on the test set. So this is, again, a test set that was completed beforehand, completely separately, that has very good coverage of all the linguistic phenomena you would want to have in an NLI data set. And you can just see that this method works much better. And one possible explanation for why this would work better is just because it's much more diverse. So it has more unique unigrams, bigrams. It's much less similar to each other. The examples are much less similar to each other. It's just more sophisticated language, etc. So I think this is just a very nice way to get you higher quality data, not just testing data, which is what this started out as, but also training data. And so I guess one of the questions you can now ask yourself is, why should we even do traditional static crowd worker data collection when we can also have humans and models in the loop? So there's still a lot of work to be done around how natural is the data. How does it relate to other machine learning frameworks? Can we incorporate knowledge about the model that we use in the loop in the optimization procedure? Can we explore ensembles, different scoring functions, and things like that? So ultimately, our goal is to really solve language. And I think, as I said in the beginning, so I've been accused of underhyping AI, so I need to be careful. But I think you can believe some parts of the hype, in the sense that we're doing pretty great at a lot of these IID problems, but I still think we have a long way to go before we can have truly general language understanding that encompasses all of the things we would care about when we deploy these models with real humans. And so a different way to put that is that we're pretty good at the head of the distribution here, or the average case, which is what you would get if you do maximum likelihood estimation on IID data of sufficient scale. But I think we're still very bad at the worst case. And ultimately, the worst case is what humans expect each other to be good at as well, because that is essentially what strong generalization is all about. So we have a lot of work to do. So as a part of my move from Facebook to Hugging Face, Dynabench also left Facebook and joined this organization called ML Commons, which, if you haven't heard of, I recommend you check out. And we're teaming up with DataPerf. So these are the folks from this very interesting paper on everyone wants to do the model work, not the data work, data cascades in high stakes AI. So there are some announcements for that coming soon. So I still think there's a bright future for doing work on this and trying to take things to the next level. That's all I had. Thanks very much to all of my collaborators, and thank you for listening.
Great. Thanks a lot. So we have 3 minutes for questions. So I'd like to put one from the online, and then we'll have hopefully one from the audience here. So the first one is, it's from the same person, I'll pick one. How did you define fairness and robustness in earlier?
Yeah, that's a great question. So we're doing heuristic, and in the current implementation on the platform, we're doing heuristic perturbations. So if a sentence contains the word he, then we're replacing it with she, and we're making sure that it's still factually consistent. And then we look at the delta in the prediction. So how much did that change your prediction? So we have some follow-up work on fairness perturbations, which will be presented at EMLP, where we show that you can do this in a very clean way using machine learning methods. So not just heuristics, but the actual rewrites based on a large data set. The example is like, if you have John really liked the German restaurant, that should have exactly the same entailment or the same sentiment label as like, Jamal really enjoyed the Mexican restaurant.
Mm-hmm. And one more question from the in-person audience. Yep.
Hi, Douwe, this is Angeliki. Hello. So the dynamic evaluation is very cool. One thing that we have problems with the current generation of models is we are somehow very bad at really understanding what our models can do. And personally, I get a lot of intuition by reading Twitter because people are trying things and, they're saying, oh, I tried this and the model can do X, Y, Z. However, this is not systematic, definitely. So do you see a way of creating some systematic, some systematic way for us to really understand what new capabilities the models have?
Yeah, I think you can do that. So we have this paper on DynaSent, so doing dynamic sentiment analysis. And one of the cool things we explore there is trying to prompt the crowd workers to attack the model in a particular way. So rather than just saying like, come up with something like creative, we tell them like, hey, you might want to consider like going along this axis of attack. So I think then as a community, if we agree on what are interesting prompts to give to our annotators so that they can try to attack or like probe a model in a particular way, I think that's a way to steer the dynamic adversarial data collection process.
Great. So I think it's time to thank Douwe again.
Thanks for having me.